Sideman. He is an organic crop specialist. His bio says he's a city boy. He grew up outside of New York City and within sight of the Empire State Building, but over time he migrated north and he got his bachelor's degree in science at Cornell in agriculture and his master's in science at Northeastern in biology, and he went on to get his PhD at UNH in botany. So currently he is hitched up with MOGFA, which is the main Organic Farmers and Gardeners Association. He's a soil specialist of the highest degree, so we're lucky to have him here tonight. In between the time when he was in college and his MOGFA time, he taught at Beets College for a while. He's an organic extension specialist, and I take it you probably do some work with the University of Maine in that capacity.
I work with all of the New England universities.
Listen, thanks for coming out. Eric Sideman.
Thank you, Paul. The first slide I wanted to show is this one here. This is a hot topic right now. What is really the big interesting growing phenomenon for a lot of people is the idea of not having soil at all. This is a hydroponic facility in Maine. They have something like 20 acres under glass growing tomatoes. And if you buy tomatoes just about any time of year in the supermarket, you're probably getting tomatoes that are grown hydroponically, some coming from Maine, most of them coming out of Mexico or Canada. And so my feeling is we want to avoid this, but some of you may want to just get up and go home right now, because really you can grow awfully beautiful tomatoes without soil at all. And the reason I put this slide here is to really show whether you're growing tomatoes with soil or without soil, you're really just catering to the plant. And we're going to talk about what the plants need and then go from there back to what you have to do to your soil to make it a good place for plants to grow. So, what plants need? Basically, plants really need oxygen, carbon dioxide, water, and then about 16 different nutrients. Some people think 17, depending if they need silicon or not, and then light. And the most important part for this particular lecture is that what roots need. And this is a little surprising to some people, especially those who don't deal with plants. Everyone knows roots need water, and roots are what pick up the nutrients out of the soil. But lots of people don't realize that roots need oxygen. And that's really the crux of this lecture, is to always remember that your roots need oxygen. Plants do not have the ability of moving oxygen from the air down to their roots. And yet the roots carry out metabolism, and they need oxygen for that metabolism. So every cell in a root actually needs to be close enough to some pores in the soil to get oxygen. Now, there are actually a handful of plants that don't need oxygen, but you know them all. Mangroves, rice, actually those are the only two that come to mind right away. Those two species of plants have the ability of moving oxygen through their system, but most plants don't. And so when you're paying attention to growing crops, you want to pay attention to the soil not only holding water, but holding oxygen. And so whether you're doing it in a beautiful field like that, by the way, this is Elliot Coleman's farm. How many people here have heard of Elliot Coleman? I'm judging my audience right now if you're wondering what I'm doing. So this is Elliot Coleman's farm. He's known among a lot of people as growing crops in the winter, but actually the most beautiful time to visit his farm is in the summer. Or if you're growing them in these bags, this is that hydroponic operation. These are bags of coir or perlite or sphagnum, some sort of inert media, and then they move water through that filled with nutrients. And in a hydroponic operation, they can balance the nutrients exactly right. They give them the 16 nutrients in just the exact proportion. But also moving through there is air. And that's going to be a key for a hydroponic operation too, that you have enough air dissolved in the water. And all of you have seen what happens if you don't have the air. I remember, I can't remember how many years ago it was, but probably 5 or 6 years ago, we had a really wet May and June. It's actually been fairly common now, but there was one June where we had 17 inches of rain, and all the fields were totally waterlogged. And if the field gets waterlogged, that means all the space in the soil that should have air in it, so the roots can get some air for their cells, don't have air in them anymore because all those spaces are filled with water. And that's going to be what we're really trying to do, is trying to avoid that happening. And you're not going to be able to do that if you get 17 inches of rain. And you've all seen what happens. If you get waterlogged soil, the roots start dying and your plants start yellowing because they don't have the nutrients. Actually, what you may see in some situations is the plant actually wilts. And so here you have a plant sitting in essentially a waterlogged field and it's wilting. And the reason it's wilting is the roots have died and they can't absorb water anymore, and so the plants wilt. This actually happens, I'll keep making, and I haven't said this myself, but Paul says this. I'm asking myself the first question to try to get you guys going. I can get back to where I was, so if you ever have a question, just shoot up your hand. It reminds me when I said plants wilting is that we're in the springtime, and one of the most common questions I get when I sit at my desk, and by the way, I didn't even tell you what I do for MOGFA. Mostly they pay me so I sit at my desk, because if they didn't pay me, I wouldn't be there. I hate being at my desk. And I answer questions, and I had email on the first slide. It's Sideman@MOGFA.org. MOGFA pays me to answer those questions, so feel free to call me or email me a question anytime. This time of year, a couple of months from now, the most common question I get is, I put my cucumbers out and they wilted and died. And of course what this is a novice gardener who's put their cucumbers out in May when the soil is still cold. And the reason they wilt is not because they're dry, because the soil is so cold, and cucumbers are really sensitive to cold soil. The roots die and the plant wilts. That has nothing to do with today's lecture, but I had to throw it in. So remember, what this is all about is getting the roots what they need: water, held in either this media or in the soil, space for air, and the nutrients. And so the components of soil, if you go to an NRC lecture, an NRCS lecture or a soil scientist lecture, they always show this slide. Most of the soil, 45% of it is going to be minerals. This is the parent material, all of the rock that's broken down over the thousands or millions of years. That parent material has mineral fractions in it. Some of them are plant nutrients, most of them are not. But it's a very important component of the soil. 25% air, 25% water. And actually, most of this lecture is going to be about this little 5% organic matter in the soil, because you really cannot really change the mineral component of the soil. I'll come back to that in a second. You can change how much air and water is in the soil, and you are going to see that managing the organic matter is the way you do this. A couple of terms to learn today. One of them is the term soil texture. This is actually referring to the size of the particles of the parent material. And you know this already, sort of layman terms: sand, silt, and clay. And what sand, silt, and clay refer to is the size of the particles, sand being very coarse particles, silt being medium-sized particles, and clay being tiny particles. And if you mix them in different proportions, you get all of these names of soils that you hear sometimes, and you probably have in the back of your head someplace. Loam is actually, this loam right here is an ideal mixture of sand, silt, and clay, because you end up with just the right amount of sand, which is coarse and has big spaces between it and allows for air. But the problem with sand is it's too coarse, the spaces are too big, and the water drains right through it. So sand tends to be really droughty. And clay being the tiniest particles, very tiny spaces between them, which is great for holding water, but sometimes it holds too much water, and so clay soils tend to become waterlogged. The other difference between clay and sand is clay has electric charges on them. We'll come back to that in a second. But those electric charges can hold some of the plant nutrients. And so clay tends to hold a lot of nutrients. It can be a very fertile soil. Sand has no ability to hold the nutrients, and sand not only loses its water, but tends to lose its nutrients too. And so ideally, if you were building your own soil, would you want something right in the middle here that has a nice mixture of sand, silt, and clay, so it holds water, has space for air, and can hold nutrients? My favorite slide, by the way. I used to love these when I was a kid. The Drake's coffee cake. And I stick this slide in here because that top of the Drake's coffee cake is the exact appearance you want your soil to have. It's a crumb-like structure. And so you want your soil, your goal as a farmer or a gardener is to make your soil look like the top of a Drake's coffee cake. Really what's happening here is you get these particles of soil sticking together. The little tiny particles that are too close together because their spaces are too small and they tend to get waterlogged. If you can get the tiny particles to stick together and make aggregates, then you make bigger spaces in the soil. You develop this crumb-like structure, and when you have that, then you have spaces that are big enough to let water percolate through and air be there for the roots. And if you want little tiny particles that can hold water, little tiny spaces in these crumbs to hold water, big particles to hold air, and then intermediate particles to do both at the right time of year. And so this is what you're actually aiming for, is developing this crumb-like structure. And what creates this crumb-like structure is actually organic matter. As the organic matter decomposes in the soil, it releases cement called glomalin. And this cement holds the particles together, creating that crumb-like structure. And so you actually, when you look at organic matter, there are all different kinds of organic matter, of course. There's leaves and straw and manures and compost and so on. But they fit into three categories. These categories were developed by a soil scientist at the University of Vermont, Fred Magdoff. And the living, the dead, and the very dead. The living is obvious, it's the plants that are growing. The dead are things like dead plants, so oat, mulch, straw, leaves, or dead crop debris. Those are dead organic matter. And the very dead is what's called humus. If you look at soil, the organic matter in the soil, some of it is fresh and decomposing, and some of it has decomposed to a very resistant state where it's slow to decompose. Oh, thank you, Paul. That very stable organic matter in the soil that's very slow to decompose is humus or compost. When you build a compost pile, really what you're making is you're making humus, except you're making it in a pile so you can put it where you want it. And humus is what's developing in the soil naturally. Looking at this table, you can see that we now look at the soil organic matter in two different groups. This is the way I used to look at it, as raw or humus, very stable organic matter. And so Fred Magdoff's living and dead and would be in the raw because they can be attacked by the bacteria, and the very dead is very stable. These types of organic matter have different functions in the soil. And it's important to remember this because you as farmers or gardeners have to think about what your soil needs to know what kind of organic matter you need to add to the soil. And let's go down the list. Now we'll start with the humus, the very dead organic matter that's either compost or naturally in the soil. This has come from organic matter. That organic matter is made of all different kinds of nutrients, minerals, various kinds of elements and compounds, and as they decompose, they release it back to the next generation of crops that's going to be growing. And so this very dead organic matter, even though it's decomposing slowly, is actually a tremendous reservoir of nutrients. Compost is very slow to release its nutrients, but you can build up a gigantic reservoir of nutrients in the soil by adding compost. The other thing that humus does, the very dead organic matter, is it increases what's called a cation exchange capacity. This is a long name. Farmers probably know it. Most gardeners probably don't know it, and chemists know it. What it's referring to is the ability of the soil, or the organic matter in the soil, to hold cations. What a cation is a positively charged ion. And there should be some question as to what's an ion, but maybe everyone remembers their chemistry. What's an ion? If you think of salt, The salt on your table, and everybody probably realizes that salt is sodium chloride. They've probably heard that term at some point. If you take that salt and put it in a glass of water, you actually do not have sodium and chloride anymore. You actually have them separate. You don't have salt anymore. You actually have sodium and chloride separate from one another. Instead of having sodium chloride as a compound, you have sodium ions and chloride ions. And they stick together because one is positively charged and one is negatively charged. The sodium has a positive charge on it. The chloride, which is actually from chlorine, when it gains an electron, it becomes chloride. It now sticks together. These positively charged ions are called cations. And it turns out that a lot of positively charged ions are plant nutrients. In other words, they're ions that plants take up as nutrients that they need to go. Potassium, calcium, magnesium. These are all positively charged ions that plants need. And it turns out that soil clay particles and organic matter have negative sites all over them. And because of those negative sites, they hold on to the positively charged ions. And so your humus can add to your ability of the soil to hold plant nutrients. So that's your function. So now you think of it, if you need more nutrient holding capacity, if you need water holding capacity, if you want to build up a reservoir of nutrients in the soil, then compost is the thing to add to you. Look at the, yeah.
The images in the bottom right corner. Can you explain?
Oh yeah, these are actually schematic drawings of a piece of organic matter or a piece of clay that have negative sites on them that hold the positively charged ions. So if you had a soil that was very low in potassium, very sandy soil, and every year you had to add more potassium to that soil, the way you would improve the potassium holding capacity of that soil would be to add compost to it, because the compost was made of organic matter that had negative sites on it. The raw organic matter, or what Fred calls the living and dead organic matter, has different functions. It provides soluble nutrients because it's raw, it's more quickly attacked by bacteria, and the bacteria quickly decompose the complex compounds. All the proteins and fats and carbohydrates in that plant are now being attacked, or in the manure, by the bacteria, and they quickly release nutrients. So if you want to fertilize a crop, you don't want to add compost because the nutrients in compost are actually really slow release. If you want to build up a reservoir of nutrients, then you use compost. If you want to fertilize a crop, then you want to add something that's fresher, like manures, or a legume cover crop that we'll come back to in a couple of minutes. These are going to decompose quickly and provide soluble nutrients very quickly. The most important thing are right here as far as this lecture goes. They provide food for the microbes in the soil. At the heart of organic farming is this idea of maintaining a biologically active soil. Lots of microbial activity in the soil, because as an organic grower, you're depending on this recycling of nutrients, whether you're using cover crops or green manures or livestock manures or compost. You want whatever it is to be attacked quickly by bacteria, and so you need to feed them. If you stop using manures or stop using some other source of food for the microbes, they will eventually die. And lastly, as those microbes feed on the organic matter, they release the cements that glue the soil particles together to form the aggregates, to make it look like that Drake's coffee cake.
Excuse me, I have a question about that slide. Can you go back?
Sure.
You're saying that those little brown things there, they're negative ions. So if you add
So
positive ions...
they are actually soil particles, and on the
Right.
surface of the soil particle,
negative.
there are negative
So if you
sites.
add positive ions, wouldn't they...
They stick to it, and
Yeah.
that's exactly right.
Is that
and
what
so,
you want then?
Yes,
Okay.
but you want those positive ions to be particular things. That's actually a very good question. When I give a soil lecture in a class, I ask this question: can you have a soil that has a very high cation exchange capacity, which means it has lots of negative sites on it, and still have low fertility? Yeah, and the answer is yes, because it depends which positive ions you have there. So you want potassium, magnesium, calcium, those are plant nutrients. You don't want aluminum or sodium, because those are not plant nutrients, and they're filling up your sites. And your goal actually as a gardener or a farmer is to bounce off the useless positive ions from these sites and add good ones. And then actually you've been doing this all your life. Every time you add limestone to a field or to a lawn, what you're doing is adding lots of calcium ions, because there's so many more calcium ions in the solution now. It's almost like musical chairs. These negative sites hold the ions, but they don't hold them forever. They're always coming off. They're always in flux and going into solution, coming out of solution. And what is ever more prevalent in that solution is more likely to grab those sites. And so by adding limestone to ground limestone to your field, you're adding a nutrient, calcium. And that calcium now fights off the aluminum and the hydrogen and the sodium, and it grabs those sites, and you've made your soil more fertile. That's a great question. So a range of soil care, no soil at all. This is soil that's just been beaten to death, and that again is Elliot Coleman's farm, beautiful piece of soil there. I put them in there because most of us are someplace in here, between babying the soil like Elliot does, and really brutally beating it up. We always fall in the middle, and we always have this dream to move this way and take care of the soil much better. Don't work it with your tiller when it's wet. Keep the organic matter level high. Always have it covered with a cover crop. And the reason you want to do that is you don't want to destroy those aggregates. You want to maintain that crumb-like structure. This spiral I really like. I'm not sure you can read that from back there. I notice now that these are too small a font. But essentially here, intensive tillage, too much soil erosion, insufficient added residues, organic matter, and it leads to your organic matter levels going down, your aggregates breaking down, and then it sort of spirals its way down, and you go like this if you don't take care of your soil. And so really the take-home message from this lecture is to take care of your soil, and the most important part of that taking care of the soil is feeding everybody who lives in it, maintaining that biological activity so the organic matter is cycling through the soil, being broken down by the microbes living in the soil, releasing the cements that hold the aggregates together, so you maintain this good soil structure that allows for good drainage and good nutrient holding capacity. This is recent work that's being done at the University of New Hampshire. I'd like to say I'm doing it, but I'm not. Stuart Grandy and a graduate student did this research, and I really like it. On this bar graph, what you see is the different types of inputs that are added to the soil, and then they measured the amount of microbial biomass, how much bacteria is in the soil after adding these different kinds of organic matter to the soil. And the most important take-home message from this, because this is where the real detriment occurs, is if you add no organic matter to the soil, your microbial activity goes down. And you could eventually reach zero. There are what are called dead soils, where farmers have essentially just used synthetic chemical fertilizers, bags of 10-10-10 or something. They've never added any organic matter to the soil. And after 10 or 20 years of doing this, there's just no microbial life in the soil anymore at all. And they are essentially, even though they're outside farming in their fields, they're farming hydroponically. They're buying bags of fertilizer and feeding their crop. Where in the organic world, the motto of the organic, or the mantra of the organic farmer is feed the soil, not the crop. What you want to do is build up reservoirs of nutrients in the soil, maintain good organic matter, maintain the ability of the soil to hold the nutrients. And it's done by adding this organic matter to the soil. Yes?
What's FYM?
Everybody asked that question. I was waiting for it. And it's simple. It's farmyard manure. I had the same question. I had no idea what FYM is, but then I saw it in some old text. So FYM is like just a mixture of different kinds of manures on the farm.
How raw are these inputs?
Well, it doesn't really matter because, but you bring up an important point to me. One thing that's missing from this chart, and I really wish it were here, is compost. I wish there were another bar graph to see the microbial activity of compost, because I think we would see compost to be someplace down here. And the reason that is, I actually think I have a slide of this, but I'll say it right now. Compost has already been attacked by the bacteria in the compost pile. It's already been chewed, you could say. And so it is not going to feed the microbes in the soil. It's actually fed the microbes in the compost pile. You're adding a really valuable, stable organic matter to the soil that's going to increase cation exchange capacity and be long-term fertility, but it's not feeding the microbes. In order to feed the microbes, you want to add one of these manures, or we'll look at some other examples of them in a second. Yeah?
Is the assumption here that you're spreading manure versus a pasture where manure is being spread naturally, or is there a difference?
There's a slight difference between that, because when manure is being spread naturally, it's not adding anything to the soil. It is actually recycling what's there. It's changing the form of it and making it more digestible by the bacteria. But all of the nutrients, the phosphorus, potassium, magnesium, that was in the grass, went through the animal and goes back. You're not adding any new nutrients. We're here, if you're actually taking it from the barn and putting it in a vegetable field, you're adding nutrients to the field. So you can't get increased fertility by pasturing animals. You can get increased availability of the nutrients unless you're feeding the animals. One of the best ways to improve a pasture is actually feed hay out on it. And then you're adding lots of organic matter in and running it through an animal, so it's in a nice form of manure out to the field. And so we do this actually at home. Paul mentioned I have a farm. I have a pick-your-own strawberry business. It's all small scale. It's like a homestead. Becky and I essentially raise all of 90-something% of all of our food. And we raise sheep. And we rotate around our different pasture, which one we're going to feed hay in late in the fall. Because the pasture is not growing anymore, but we don't want to bring the sheep into the barn yet. And so we put a hay rack out in one of the pastures and start feeding hay out there. We pay a fortune for the hay, but we think of it as fertilizing the pasture, buying hay from our neighbor, using those nutrients to refertilize one of our pastures, and we rotate which one we're going to do around.
So we have like maybe a 20 by 60 foot garden, smaller, divided up into smaller plots. Is it important for us to rest some of our plots?
Yes, that's an interesting question that goes beyond the scope of this lecture. So it's the idea of incorporating crop rotation into a garden system. Farmers tend to use vegetable farmers use crop rotation to avoid insects and diseases by planting something here one year and then tricking the insect and planting it there the next year, and that there being a mile away or thousands of feet away, that insect wakes up and there's nothing to eat and it dies. And so that's crop rotation. And it makes sense for pest management on a farm, but it makes no sense for pest management in a garden. And the reason is almost anything can move from one side of the garden to the other. You don't have enough distance to rotate. But rotation still is important in a garden for building the soil or managing weeds. And so I like to recommend to people they have more than one garden. So back in I guess we're a farm, but we have 4 or 5 different fields on our farm, and we rotate around. And some of them are really small gardens, but our solanaceous crop, for example, is never in the same garden this 2 years in a row. 1 year it's here, 1 year it's there. In a garden where you only have one garden, you could divide the garden in quarters and actually have 1/4 of your garden that's out of production every year. That 1/4 of your garden is going to be growing a green manure crop. And we jumped ahead here. I'm going to talk about green manures in a couple of minutes. But a green manure crop is a crop you grow for the benefit of building the soil. You're not going to harvest it, you're going to turn it into the soil. If you have 1/4 of your garden where you're growing a green manure crop, you're adding fresh organic matter. You don't even have to grow a green manure crop. You could have 1/4 of your garden where you're covering it with a mulch every year and letting that mulch decompose into the soil. It's very interesting. I did grow up just outside of New York City. This was a very long time ago. I left my home just outside of New York City in the mid-'60s when I went to college, and I have not actually been back except for a 6-month stint between colleges where I lived right in Manhattan. But other than that, I edged north. The reason I bring that up now is because this was back in the 50s. My father was actually an organic farmer and had no idea he was. He grew up in the slums of New York City, knew nothing about gardening, and I can't believe it when I think back on it. The way we had our garden is he divided our garden in half. And one half we actually grew our garden vegetables in, and the other half is where he piled the leaves that he raked up in the fall. When I got old enough, we raked up in the fall. And we piled all the leaves there, and they would decompose. And then the following year, we raised our vegetables in that half of the garden, and we covered the other half. And he was doing this back before I knew what he was doing. Actually, I'm not sure he ever knew what he was doing. It was probably just a good place to put all the leaves. We had to put them someplace, but it was really the right place to put them. The other thing I want to point out is poultry manure. This is an interesting one. Look how little the poultry manure does for feeding the bacteria, improving the bacteria. And the reason is, we have a farmer up in northern Maine. He says, it's just chemical fertilizer. And the reason is poultry manure, most of the nutrients in it are immediately available. They're in a soluble form, and there's virtually no organic matter in poultry manure. Unless, of course, you're talking about the bedding. You have your chickens in your barn in a small scale and you raise them on bedding. Then you've got all of that poultry manure mixed in with the hay or straw bedding, and that's an excellent material, and it would probably be way up here someplace. But poultry manure, just the manure itself, has virtually no organic matter in it. They have very efficient digestive systems. Cows, on the other hand, have very poor digestive systems. And half the organic matter, actually, yes, half the organic matter that a cow eats comes out the back end and ends up in the manure. And so that organic matter is feeding your microbes. Cow manure is one of the best materials to add to soil to feed the microbes. Yeah.
I take issue with what you just said, that they have a poor digestive system. Because you're really looking at two different types of feed. Poultry don't eat as much fiber.
Yes.
The ruminants eat a lot of fiber.
That's
which
right.
is why we get a lot more
Yeah.
residue and the biological activity is all in the rumen.
You took that as a personal insult. You must have cows.
Guess which one I read?
No, you're exactly right. And pigs are the same way. Pigs and chickens are eating grain that's essentially very easily digested. It would be like if we lived on steak. It'd be very easy to digest it. We need the fiber, and the cows and the swine and the sheep do too. And a lot of that fiber is very resistant to digestion, comes out the back end in a great form for improving the soil. That's a good point. I'm not insulted at all. This book is not over there, and it should be. Where's Ruth? You should probably get a copy of this. It's very inexpensive. You can order it on that website right there, Building Soils for Better Crops. It's written by Fred Magdoff, who's at the University of Vermont, and Harold Van Es, who's at Cornell University. And I think actually they're both retired. I know that Fred's a friend of mine, and I think Harold is either retired just a couple of years ago or is retiring in a couple of years. Great soil scientist. And this book is what the title is. It's How to Build Better Soils.
Buy it tomorrow.
Okay, now what I'm going to do is go take what I just talked about and bring it down on the field. And let's look at a couple of examples. So this is compost right here. Commercial compost facility. This one is just north of Augusta in a town called Sydney. It's one of my favorites. It's a dairy farmer up there. And his brother runs a compost facility. And so the dairy farmer brings the excess manure over to the compost facility. And dairy farms often have excess manure, unlike beef farms. They're feeding so much grain to get a lot of milk. They're actually bringing more nutrients onto the farm than they need to grow their crops. And so you find some dairy farmers, depending on how they're running the operation and how grass-based they are versus grain concentrates, they may or may not have a lot of excess manure. This one has a lot of excess manure, and they sell it as compost. This one here, one of my favorite farmers, he has or had a compost turner that he bought with a handful of other farmers in his neighborhood. Actually, the first 3 farms that did that were right down here. And I'm having a senior moment, I can't remember any of their names. But I remember 3 farmers right down here in Hampton area brought a compost turner together. And these little things here, essentially like a giant rototiller, they're beaters right there, and it's on tracks, and it can just roll right across the compost, mixing it together. But things to remember about compost: excellent for adding organic matter to the soil, increase the cation exchange capacity, and those things, but it's already been decomposed. So if what you're trying to do is feed the microbes, then compost isn't the tool for you. You'd rather be doing something like spreading fresh manure on the farm, adding straw mulch to the fields, excellent source of organic matter. Residues from your crops. Some of them leave a very little residue, some of them leave a lot of residue, depending how you're growing the crop. And so that's an excellent source of organic matter to feed your microbes too. But my favorite is growing green manure crops. And you're going to hear more about this in a couple of weeks. Doran Cox is going to talk about this. So I'll only briefly touch the subject and show you quickly a handful of green manure crops. Why green manure junkie? I wish I thought of that phrase myself, but I can't take credit for it. There are 2 farmers down in Pennsylvania, Eric and Ann Nordell. Another quiz on testing my audience. How many people here have heard of Eric and Ann Nordell? 1. And I knew that Chuck had heard of them. They are fabulous farmers. Vegetable growers, relatively small scale, maybe 10, 15 acres of vegetables. But they built their farm very slowly, and they got every bit of it into perfect condition before they expanded and made it bigger. Totally weed-free, and they did it through crop rotation and bare fallowing. Bare fallowing is having nothing on the land at all. And so when they first plowed up the sod, they had lots of bare fallow. And what they used the bare fallow for is to beat back the perennial weeds and to try to get weed seeds to germinate and then kill them. And so you keep it bare fallow. Weed seed germinate, you run the tiller through again. More weed seed germinate, run the tiller again today. Perennial crops send up shoots, run the tiller through. And what your aim is in the beginning to have a lot of bare fallow, get rid of all of the weeds, and then as your farm gets older, to have virtually no bare fallow and always have the ground covered with cover crops. And so the longer you farm, the less bare fallow, the less time the ground is ever bare. And they call themselves green manure junkies because their favorite part of farming, like mine, is growing these green manure crops. Growing crops not with the intent of harvesting them, but turning them back in the ground. And why junkie? They say they support their habit of growing green manures by growing vegetables to sell. It's a great slogan.
You said they kill the weeds. How do they kill the weeds?
The weeds are, in their situation, it's all a horse-drawn equipment. And so they're dragging various kinds of horse-drawn cultivating equipment through the ground. And so you let the weed seed germinate. As soon as it's that big, you bring cultivator through it and kill it. And you've now used up a weed seed. You've reduced the number of weed seeds in the ground. And so every time you till it, by the way, what stimulates a weed seed to germinate is a little flash of light. And so when you run your tiller or your cultivator through a piece of ground, you've now stimulated more weed seeds to germinate. Then wait a couple of weeks for it to get about that big, and then kill it again with another pass with the cultivator. This hand first.
If you were to use a tiller, would that compromise the soil structure?
Yes, I'm glad you asked that. That's an important question, and everyone should have asked that question. Isn't this terrible for the soil? So much repeated cultivation? And the answer is yes. Every time you use a rototiller or even a cultivator, anytime you run a tractor over a piece of ground, you are destroying the aggregates that we've just spent a half an hour talking about building. All those little bits of particles that look like the top of the Drake's coffee cake are very sensitive to pounding. And a tractor tire or a rototiller is going to smash them and ruin them. And so the answer is yes, but it's necessary because the worst situation is to have too many weeds. And so what you have to do is a balancing act. All of farming is management decisions. You have to decide what is more important at this particular point of time. Feeding the microbes, building my soil, or getting rid of the weeds. And you're forever balancing that. And so this is what Eric and Ann Nordell have done. They've developed their system where they got rid of all the weeds in the beginning. And now they're just building their soil.
I've been gardening in my patch for, I don't know, 40 years.
You've been what?
Gardening in my little patch for over 40 years.
Yep.
And I have a continuous crop of weeds. I do what you do, let them grow a little bit, knock them down.
Yeah.
Next year there's a whole new crop.
Yeah.
Last year there was a weed I've never seen before. I don't know where the hell it
Yes,
came
I'm
from.
seeing weeds I've never
Phosphate
seen before.
spurge just came up everywhere.
Yeah.
Never had it before. So I assume these seeds have been here in the soil all that
Yeah,
time.
there's something. So there are a couple of points here about weed control. First of all, you should never let a plant go to seed. And that's really hard to do. I was once visiting this farm in northern Maine. In Maine they call it the county. It's Aroostook County, but for some reason it's called the county. And I was up, and this is where the big farms are. We don't see this around here, but you see 100-acre fields of just 100 acres of potatoes or wheat growing out there. And the farmers, when you go visit these big guys, they give you a tour of their farm in the pickup truck. And so we were driving around in the pickup truck, and this guy was going down the dirt road, and all of a sudden he slams on the brakes, and he gets out of the truck, and he walks 150 feet into the field. He saw pigweed growing, and he went to pull it out. Because that pigweed is going to produce about 500,000 seeds. And it came from one seed. And so every time you let a pigweed or a lamb's quarter or a gallon soga go to seed, you're 500,000 times worse than you were before you did. And this is what happens. Every time one of those weeds go to seed, they add to the weed seed bank.
I don't want to go to seed.
Yes, and if you don't ever let them go to seed, you're eventually going to win.
But 40 years.
40 years is hard to believe that you haven't gotten that out of there. Because the longest I know is lamb's quarter. Lamb's quarter and pigweed both have this innate ability to not germinate, even though conditions are perfect. And so when gallon soga is, we won't talk about weeds too much, but gallon soga releases its seeds. If the conditions are right, the gallon soga weed seed is going to germinate. And people who have gallon soga as a weed problem, it's because they've just let it go to seed year after year, and they continually let it go. You could actually, and they've tilled it in, because you bury them. And so you've got gallon soga weed seed not only in the top ½ inch where they're going to germinate, but you've tilled them down 6 or 10 inches, and so you've got a whole soil profile with gazillion gallon soga weed seeds in there. Every time you bring one up to the surface and gets a little flash of light, it's going to germinate. Things are worse with lamb's quarter and pigweed. You can bring them up to the surface as much as you want. Only a small percentage of them are going to germinate. The gallon soga can't help it, but the pigweed and the lamb's quarter cannot germinate. They have this evolutionarily adapted ability to not germinate and stay in the ground, and that way they can't get tricked. For example, with a cultivator, you can trick all the gallon soga that's up on the surface to germinate and then kill it, but you can only trick about 10% of the pigweed or the lamb's quarter to germinate, and the rest live. And so after years and years, you can build up an enormous weed seed bank. 40 years, that's amazing to me that you have not let a weed go to seed for 40 years and you still have them. That's worth a field trip for me.
I think you have another question.
Yeah, who was that? Question?
Oh, that was me, but I answered it myself.
Oh,
sort of.
okay.
I was going to ask about burning weeds,
Yeah.
but then you're using fuel.
Yes, you're
do
using
that.
fuel and you're wasting organic matter, but it can work. They do sell flamers, and I know people have built their own flamers, and if you could do the exact same thing, and it takes fewer passes with the tractor, because you could have a backpack flamer. And so you let that weed seed germinate and again then go through and flame it. and kill it. You're not actually burning it, although they call it burning. You're just heating it up and denaturing the proteins and killing it.
So Eric, it's somewhat clandestine operation. My wife and I brought seaweed back from the ocean last summer.
Yeah.
Any thoughts?
Yeah, a lot of them. My PhD at the University of New Hampshire is not in agriculture. When I went to Cornell, I studied agriculture. I had this dream of being a dairy farmer. And I worked on a dairy farm for almost a year up in Vermont. And then I had dropped out of college. And then I decided I really want to be a dairy farmer. And so like any city kid, I wanted to be a dairy farmer. And instead of staying on the dairy farm and really learning how to do it, I decided to go to college. And so I went to Cornell and I started off majoring in dairy farming. Mostly what I learned at Cornell, I mean, I learned a lot there, but one of the big lessons was that I can't afford to be a dairy farmer. It just costs way too much money to get started. I didn't have parents who owned land. I didn't own any cows. And so really what I learned is that I didn't want to be a dairy farmer. But I have a degree in agriculture from Cornell, but eventually I started to take lots of biology and botany courses, and I really fell in love with plant ecology. And my degree from the University of New Hampshire is in seaweed. You were wondering if I remember the question was about seaweed.
Yeah.
So I got a PhD studying the ecology of a brown seaweed called fucus, and I love that science. But it gives me two different ways of looking at seaweed. It's actually an excellent source of organic matter, and it's a good source of micronutrients. But the other half of me hates people taking all of those nutrients and organic matter out of that ecosystem and bringing it to a different one. And actually, there are a lot of seaweeds where you can do tremendous environmental damage if you harvest them wrong or harvest too much. And this is happening on a commercial scale now. You going down with a pickup truck and picking up the dead drift line of seaweed isn't really doing much damage, but the giant ships cutting the ascophyllum off at the bottom of the ocean or the intertidal zone at high tide is doing a tremendous amount of damage. And so,
Is it permitted?
yes, actually in Maine, where most of this is happening, there is no regulation at all. This is the most bizarre thing. So harvesting seaweed on a small scale like you do, there's actually a limit how much you can take in one day, or I think it's a day, there's a daily limit. If you harvest more than that amount, now you need a license.
Really?
And once you get your license, there's no limit on how much you harvest. There's only a limit if you're small scale. And so the commercial growers are not limited, yeah?
Well, I just remember the garden 2 years ago, and I bought bags of Maine seaweed soil.
Oh, right, coast of Maine.
Yes, and I put them in, I had the plants in pots, and they grew to be 6 feet tall, and they were like this strong with about 7 tomatoes on them. So that wasn't, I shouldn't be doing that.
Well, his compost, the Coast of Maine compost, I don't believe he uses much seaweed in that. It's mostly fish waste and cow manure and blueberry waste. The ingredients are all on it. I would stay away from like buying dried kelp and adding that to my garden. There are people who feed kelp, and I have to admit that I'm one of them, to livestock, but I feed very little of it. There is a real hazard with harvesting too much seaweed. And it's a longer story, and I won't get through these slides if I don't hurry. Growing green manures, you got to match which season. You got to choose your window of opportunity is one way of saying it. When do you not want to grow crops? And these green manures are fit various windows, summer, fall, spring, and so on. And I'm going to go quickly now through these. Dorn is going to talk about green manures, and I won't steal his thunder. I will point out that my favorite way of using a green manure crop, a cover crop, is what's called a long lay. It's taking land out of production for a long period of time, 5, 6, 7 years, putting it into pasture, which is great for the soil. And so if you could have a rotation where you're picking vegetables 1 or 2 years, and then you seed it down to a pasture, and you use it as pasture or hay land for 5 or 6 or 7 years, and then go back to vegetables, that's an excellent crop rotation, because now you have 6 or 7 years without disturbing the soil, just it's naturally adding organic matter to it, never disturbing all the critters that are living in it. Quickly, some pictures. This is actually my new farm here in New Hampshire. We just bought it and turned the field in. That's my strawberry field. Well, I don't grow Japanese millet there anymore, but that's cutting down Japanese millet. Buckwheat is a great summer crop, just like the Japanese millet is a summer crop. Japanese millet, as you can see, has vast amounts of organic matter. Buckwheat actually has very little organic matter because it's mostly water. You'll get a lot more of these. Cowpeas is a legume, which means it has these nodules on it where it has a symbiotic relationship with bacteria, and it's able to take nitrogen out of the atmosphere, fix that nitrogen into a biological compound, and then when that plant dies, it actually releases that nitrogen to the soil. And remember, nitrogen is one of the most important crop nutrients you need. And so you don't have to go buy it. If you grow legumes enough, or grow enough legumes, you can actually grow all the nitrogen you need in your system. And Doran will go through that, especially on a large scale. This one too, this is a rye. It's actually a rye-vetch mixture. I'll come back to it. Rye is an interesting one. Great fall cover crop. As you can see here, it's not meant for gardeners. Winter rye is probably the most common cover crop for farmers and the one that does the best job at holding nutrients in the fall. But not meant for farmers, it just gets too big. Not meant for gardeners, it just gets too big. Instead for gardeners, I recommend oats, and the reason is oats are winter killed, and in the spring you'll just end up with dead oats.
But just answer my question, which one is winter killed?
Yeah, so the oats will be just a mat of vegetation that's easy to handle, and that's what I recommend for gardeners. Tillage radish is a new one becoming really common now, and I think Doran will probably talk about that plenty. So this is what it looks like, and we'll let Doran tell you all about it. Hairy vetch winter rye. When I first moved to New England and started to work for MOGFA, we did a bunch of experiments with the New Alchemy Institute. Another test, mostly it's a test of age. How many people here have heard of the New Alchemy Institute? It's got to be more than joking. Yeah, great. So I worked with the New Alchemy Institute, and we studied hairy vetch winter rye mixes as a fall cover crop. It's a great way, it can be planted late into the summer, early fall. The rye grows, the vetch uses it as a trellis, excellent nitrogen fixer, and it fits this window of late summer, early fall, goes dormant for the winter, resumes growth in the spring. And so this is a great way of growing all of the nitrogen you need and adding vast amounts of organic matter without actually taking land out of production. You can grow summer crops still in that opposite window of when you're growing the vetch rye mix. Red clover, great perennial or at least long-lived biennial. And then this one is a farmer that's in Maine. It's actually a mixed operation, the Harris farm. Number of generations, some of the generations are dairy farmers, other generations are vegetable farmers, and they share land. And so some of it's producing vegetables, but not for long. And so they rotate their hay and pasture around with the vegetable land, and they really take good care of building up organic matter and soil structure, as you can see there. Cornell soil test, that's this diagram right here. I'm supposed to go to 8:30 or 8 o'clock? Some places, okay, we'll quickly go through this here. So Chuck asked me to talk a little bit about assessment. I've got mixed feelings about it. This is a test to measure how good a job you're doing at building that soil structure and building the microbial activity in the soil. The question is it really necessary? And so I'm not really sure. So the first half of the soil test is just like any regular soil test. It's going to measure soil pH, organic matter, and nutrients, the chemistry of the soil. How many plant nutrients do you have in the soil? But these other two are part of that Cornell soil health test are kind of unique. They measure the aggregate stability. How good are those crumbs you've made? How well can they stand up to pounding rain or tillage equipment or whatever? And so you can do that actually just by looking at it and feeling it yourself, but you don't get a number and you don't really have a good accurate measurement. You could send it to Cornell and they can measure the aggregate stability in the laboratory. It's up to you. If you like having these numbers, you can measure how good a job you're doing, and over time, how much better are you getting? And then the other one is even more important to me, the microbial activity. How good a job are you doing and maintaining living microbes in the soil. How do you measure that? That's really hard to actually do on your own. But they can do that in the lab, and actually now you could do it on your own too. Woods End Laboratory sells these little jars, and they can measure carbon dioxide being given off. And the amount of carbon dioxide given off is directly related to the microbial activity in the soil. And so you dry the soil, and then you wet it again, and when you wet it, you get a burst of activity of the microbes, and they've developed a scale to measure that, and you can, with that scale, say, yes, I'm doing a really good job maintaining microbial activity. Up to you, and you should probably read this Cornell Soil Health Assessment, and it's actually online too. You don't need to buy a copy or take that one. How much longer do you want me to go?
Keep going.
Keep going. Okay, so this is the other half of it. The first half was all about, it's not as long. I saw that nervous face. It's not as long, it's a short piece here. I'm going to go very quickly through 4 or 5 slides, maybe a little bit more than that. This is the chemistry. The first half of it was building the structure of the soil, holding the air, being able to hold the nutrients, being able to hold the water, being able to let the water drain through the soil. All of that is based on that managing organic matter in the soil. This is the chemistry. Do you have the nutrients in the soil to grow the crops? And it's a strictly yes or no answer. And you can send a soil sample up to the University of Maine or to the University of New Hampshire, and they'll send you back a result. And these results are essentially telling you you have very low phosphorus or potassium or optimum levels and so on and so forth. We're not going to get into the detail of that. I had to show this slide, second favorite slide. This slide is all about what organic farming is not. Okay, another quiz. Kestrel-Levine. How many people have heard of Kestrel-Levine? Public radio junkies? Nobody? Kestrel-Levine used to do these essays on public radio. When the government started to cut the funding of public radio and they ran out of money, they started to fire people. And one of the people they fired was Kestrel-Levine, which was really sad. She did these gardening essays that she would read. But she told a story about her father and her growing up and how much he loved Miracle-Gro and how he grew these wonderful roses. And then when she grew up, she immediately started to use Miracle-Gro too, because it did such a good job on her father's farm. But as she got older and became involved with organic farming and the sustainable agriculture movement, she realized that her job as a gardener was to take care of the soil, just like the job of a farmer is to take care of the soil. And what she decided was, and this was her quote, "Good soil husbandry does not come in a box." And that's exactly what this is all about. And it actually goes back to that slogan about organic farming. Organic farming is all about feeding the soil, and then the soil will take care of the crops. This is only feeding the crop. What's in that box is a box of chemical salts. And some of them are positive cations that are going to get stuck onto the cation exchange capacity. Some of them are other sorts of nutrients. But everything a plant needs is in that box. And you don't need soil at all. It has nothing to do with organic farming. Organic farming is all about feeding the plants, feeding the soil, adding nutrients that are eventually going to reach the crop. So I've got a handful of slides here. They're going to talk about you have to get the nutrients to the crop in order to grow the crop. It needs phosphorus and so on. And these are the things that get the phosphorus into the soil and make it available to the crop. And so the thickness of the line is actually what you would like to have. The thicker the line means you like that if it's going in, and you don't want a thick line going out because what's going out are the nutrients being lost. So leaching. Actually, not very much phosphorus is leached because it's not particularly soluble in water. Most of phosphorus is lost through erosion. Thin lines, though, because you don't want that. Crop removal, that actually I should have made the line thicker for farmers, actually for gardeners too. Everybody wants to remove the crop because you want to eat the peas or sell the beans or whatever. So crop removal means you are taking phosphorus away from the system. That means you have to add it again. Every time you sell a dozen ears of corn, you've sold a certain amount of potassium, phosphorus, nitrogen, and so on, and you've got to replace it or you'll deplete your soil. And so this is things that have to go back in here. Compost and manures, soil minerals, lots of phosphorus is actually in soil minerals and in flux of going back and forth all the time. And your job is to build up the actual total amount of phosphorus that's in the reservoir in the soil minerals. Soil organic matter, lots of phosphorus in organic matter. And actually, this is where most of the phosphorus in organic farm should be coming from, is the reservoir of soil organic matter. So you have to be adding very little of these other things during the years. One of the first questions I got when I started to work for MOGFA, I got wrong. I always remember it. Somebody called me up and said, can you have too much organic matter in your soil? And I said, no, organic matter is great. I can't think of why you could have too much organic matter in the soil. And then eventually, I got the right answer. Phosphorus is not very soluble. And I remember these trials we did at Cornell when there was a student there and how little it moves in the soil. But a little bit of it is soluble. And if you have a lot of phosphorus in the soil, that little bit can be too much. And it goes back to ecology of aquatic systems. Phosphorus is the limiting factor to the growth of algae in lakes and streams and ponds. And if you end up putting too much phosphorus in that aquatic system, you get an algal bloom. And if you get an algal bloom, eventually it dies and it decomposes, and as it decomposes, it uses up the oxygen and the fish die. And this essentially is a short lesson in ecology of why you need to keep phosphorus out of the system. And so going back to that answer, can you have too much organic matter? Well, the answer is actually yes. Mostly your phosphorus is going to stay in that organic matter, but a tiny bit of it is released every year. If you've added compost to your garden year after year after year, and your organic matter level in your soil is now 15, 20%, you've got too much organic matter. Because that little bit that is being released every year from such a giant pile is too much for the environment. It's more than the crops need. And if you're putting more phosphorus soluble into the system than the crops take out, it's washing out of the system and ending up in an aquatic. So there's your answer. You can't have too much organic matter. These are where organic farmers and gardeners get their phosphorus. Probably the most favorite one is compost. If you get your soil test back and it says you have too much phosphorus, stop using compost. Use it someplace else or sell it, because you don't want to keep adding compost to your phosphorus is too high already. These are other phosphorus sources from various natural rocks have phosphorus. Bone meal has phosphorus, a lot of it, and chicken manure has phosphorus if it's coming from layers. Potassium, a little different than phosphorus in that the potassium is very soluble, and you actually don't want to add potassium to the system unless you need it at that time. If you add potassium to the soil in the fall, it'll probably be all lost by spring. So one of my common questions I get, wood ashes, should I put it down in the fall? And the answer is no. First of all, you don't use wood ash unless you need a pH adjustment. And two, wood ash is a great source of potassium. And you don't want to add the potassium in the fall because it'll be gone by the spring. So get a metal drum, save you wood ashes, only use it where you need potassium and a pH adjustment, and only use it just before you're planting your crops so they can get it from it. Very soluble, we said that already. Luxury consumption is all about some crops that actually pick up more than they need. And microbes, this is an interesting one. Microbes have very little use for potassium. That's why you need to use it only when you need it. If you put phosphorus down in the fall, it's either going to get locked up in a chemical compound, or the microbes are going to take it up and incorporate it in their bodies. But for some reason, microbes have very little use for potassium, and so if you put it down, it'll be lost. It's not picked up. Nitrogen is the same way. We'll come back to nitrogen in a second. These are the sources of potassium on an organic system. Compost and manure, again, is a fairly good source, but for the most part, you're going to get it from one of these minerals. Wood ash, if you need the pH adjustment, Sulfomag if you also need the magnesium. Green sand and granite dust, I think they're way too expensive for the amount of potassium. One of the ways of figuring out which source you use for a particular nutrient is dollar per pound of nutrient. And there's some great books out there that will tell you how many pounds of actual potassium is in a pound of green sand and how much of it is actually available. And it'll turn out you'll spend a lot of money on green sand before you get enough potassium to make a difference. And if you have granite dust for free because you have a quarry, maybe, but to buy granite dust doesn't make much sense to me. Potassium sulfate is a tricky one. It's probably the best source of potassium. It's 50% potassium. At $1 per pound of potassium, even though it's a very expensive material, it's probably one of the best ones, but it's tricky to use because you could put down too much very quickly. And straw is an interesting one. Remember the last slide, those of you who are still listening, I feel like I'm boring myself now. I mentioned luxury consumption. What that means is plants take up more than they need and they end up to actually be a reservoir. The grains like oats are luxury consumers of potassium. And one great way of getting potassium into the system is using straw mulch or straw bedding for your livestock and then spreading the livestock manure. And you're getting free potassium from that straw as well as the organic matter.
Eric, what about hay?
Hay is not a luxury consumer, but it will have potassium in it for sure.
Unless it's a legume.
That's right, legumes have less.
We'll also have lots of weed seeds.
Yeah, so we're going to need all sorts of things. I tend to stay away from hay as a mulch because of the amount of weed seeds. But it works really well, and if you're willing to lock yourself into always using a mulch, then it doesn't matter if you have the weed seeds. But if you're ever planning to have a place without the mulch, then you don't want to use hay because you'll be adding all sorts of things. Okay, 5 minutes on the nitrogen cycle, and then I'm going to go home and have dinner. The nitrogen cycle is very important to me because it is the limiting factor to plant growth in a terrestrial ecosystem, including agricultural crops. In most gardens and farms, the nitrogen is the first thing you pay attention to. You want to make sure you have enough nitrogen or you won't get a decent yield. The other thing with nitrogen is that you need to have a nitrogen cycle happening on your farm. The green arrows are showing what you want to see, even though they don't show up that well. You can see from livestock manure or a legume crop, the proteins in that are attacked by bacteria. It'll be on the course for people who don't have chemistry, but those proteins are broken down, and one of the waste product of the bacteria that break down those proteins, that are using those proteins as food, is an ammonium ion. Plants can pick up ammonium ions. Plants can't pick up protein. You've got to have at least this step, and most plants pick up their nitrogen as a nitrate ion. And so there's another set of bacteria that actually use the ammonium ion as a food source, and their waste product is the nitrate ion, and that's where the crops are really getting their fertility. And then the plants pick up the nitrate ion, and you want to have this circle going round and round and round. Proteins attacked by bacteria, ammonium ion attacked by bacteria, nitrate ion picked up by plants that are eaten by the livestock. And that's what you'd like to see happening on your farm or in your garden. The problem with nitrogen is how easily it's lost from the system. First of all, the ammonium ion is not lost too badly, but the nitrate ion is negatively charged. This would be a point where I'd ask a question, but I'm getting really hungry. And so the ammonium ion, I'm just going to tell you, has a positive charge on it. So if you have a good cation exchange capacity, it will be held in the soil and not lost to leaching. The nitrate ion is a negatively charged nutrient, and it is very susceptible to leaching. Remember back when I started this, I was talking about that June we had 17 inches of rain. Not only were the roots killed by the waterlogged soils, but there was no nitrogen left in the soil at all. Everybody had to refertilize to get a decent crop that year because the nitrate was lost. Especially the chemical farmers, because they put down ammonium nitrate, and the ammonium part of that compound, ammonium nitrate, may hack around, but most of the nitrate was lost that month of June. and actually even some organic farmers, because if you put down manure in the end of April, by June, most of that manure was sitting in the nitrate form. 60 days, you probably have 50% of it in the nitrate form, and it's lost. So leaching is the movement of these nutrients down, dissolved in the water that's percolating through the soil. This is different than erosion, by the way. It's water moving across the surface. Yes, volatilization. And so volatilization is actually this ammonium ion reverting to ammonia gas. This is a natural phenomenon. It occurs, it's a very unstable form, especially if it gets dry or gets wet and then dry. The ammonium ion quickly turns to ammonia gas and goes up into the air, and that's called volatilization. By the way, for those farmers here who are chemical farmers and use urea, I always tell people to not spread something like urea or chicken manure, which is really very much like urea, and then go inside and have lunch. Because if it's sitting there drying in the sun, you're going to lose half of it as ammonia gas. You want to spread it early enough in the morning that you can incorporate it into the soil right away and capture that ammonia in the ground. And then last, denitrification. This is actually, denitrification is the opposite of turning proteins into nitrate. Now you're turning nitrate into the nitrogen molecule that's in the atmosphere. And this too happens naturally, and it happens when bacteria are not available or plants are not available. It happens when bacteria are not available to capture the ammonium and bring it into the nitrate form, or plants are not picking up that nitrate form. It happens in waterlogged soils, and the nitrogen is lost to the atmosphere as nitrogen gas. And so you see there's tons of ways you can lose it. And if you get good, you can actually think about when you added what material to the soil and where in the nitrogen cycle is it and what losses it's susceptible to. Is your ground waterlogged? Is your ground getting dry? And so on and so forth. That's my last slide, I know it. And I'll prove it. It's not that I've gotten so hungry. Oh, I was wrong. Not my last slide. Nitrogen sources for organic farmers. Legume cover crops are the prime one. They have the least environmental impact because essentially you're taking nitrogen out of the air, putting it in the crop. You're not buying nitrogen. You're not using energy to create nitrogen fertilizers and so forth. Livestock manures, seed meals, and fish meals are the other kinds of sources that organic farmers and gardeners use. All right, questions, general questions that we didn't talk about. And don't worry about my hunger. I just look forward to dinner more when I get hungry. Yeah?
I haven't heard you once mention carbon.
I didn't mention carbon, you're right. Carbon's an interesting one to me. Carbon is another way of looking at the organic matter. We actually have talked about carbon. We just didn't mention the word. When you talk about adding carbon to the soil, it's not actually adding carbon atoms to the soil. You really wouldn't get much out of dumping a whole truckload of coal into the soil. What you're talking about when you're adding carbon to the soil are carbohydrates, fats, proteins, organic molecules that carbon is the kingpin of. Remember, carbon in the organic molecule is the building block of that organic molecule. And the reason you want to add carbon to the soil is because you're feeding the microbes. They need those proteins and carbohydrates and fats to grow. And so your carbon cycle is turning that straw into the soil, having the microbes eat that straw, using those microbes in the soil to hold nutrients for you, have those nutrients recycle, growing more carbonaceous material by taking carbon dioxide out of the atmosphere, using the nutrients that have been recycled by the bacteria, and you keep sequestering more and more carbon dioxide out of the soil in organic matter in the soil. That's where carbon fits in. Yeah?
So what's the fine line between percentage of organic matter, which is made by bacterial breakdown, releasing carbon dioxide, as opposed
Yeah, that's an interesting question. I have to think about that one. If you're promoting microbial activity, you're releasing carbon dioxide into the atmosphere. And so you have to have a balance of only enough microbial activity to get the nutrients, because you actually want to delay the breakdown of most of your organic matter. That's beyond my ability at the Sunger level.
All looks
That's
good on
really,
paper, doesn't it?
Hmm?
It all looks good on paper.
Yeah, it really does, but you raise an interesting question. So you don't want, I mean, this question that was raised, what he's bringing the point to is you don't want to have a massive amount of microbial activity using up all the organic matter you have in the soil, because that's putting it back into the atmosphere. You want to sequester it in the soil, and so you want to have a balance of microbial activity in the soil. And it's an interesting question. I never thought of that before.
Good research project for you.
It is, but it's not for me. It's for Stuart Grandy, who's a professor at UNH. And next time I see him, we're actually going to talk to him about this. Or actually, there's some Sarita Fry. I don't know if you know her. She's a soil biologist as well. And Sarita works in natural systems. Stuart works in both natural and agricultural systems. Very interesting question.
2.5%.
I think you would like to see organic matter in the soil someplace between 5 and 7%. And how you maintain the microbial activity so it's not too fast burning it up. Or at least you're adding, maybe that's where it is, you're balancing that organic matter in the soil by adding organic matter as quickly as you're losing it. So you're not adding any carbon dioxide to the soil. In other words, you're growing cover crops and tilling them into the soil at a rate that's adding carbon to the soil as quickly as you're losing it. Does that make sense?
But then how do you get it into the soil?
Well, if you till that into the soil, you're adding all that carbon dioxide that is now carbohydrate into the soil, and it's going to end up in the bacterial populations.
Which again is another problem, because if you till that soil, then you're adding
Add to the soil, speeding up the micro. You know what? Actually, this comes back to, this is why the lay is the best, because you're not tilling the soil and you're limiting the microbial activity by limiting the amount of oxygen in the soil. That is basically the limiting factor to microbial activity, is how much oxygen. Yeah.
I was just going to mention that I actually work with Sarita Fry.
Oh, you work with Sarita? Are you a graduate student?
I'm a postdoc, actually.
Oh, great.
I'm studying this exact question of the efficiency of microbial use of organic matter. So we're trying to develop some new techniques to measure what portion of the organic matter that the microbes are actually using to keep in the biomass, in the microbes themselves, versus what they respire and turn into CO2. So the jury is still out. But
So the other question is, what types of bacteria are going to be the most efficient?
Yep, exactly. And what types of environmental conditions influence that efficiency too. So there's a lot of fear that with warming, the microbes become less efficient. And so they're producing more CO2 for the amount that they eat, which then re-radiates and causes more warming, which then feeds back and causes less efficiency. But we also recognize that there's probably fungi that are more efficient in the soil. So they tend to retain more carbon as biomass, as opposed to the bacteria, which seem to be, in general, less efficient. So they tend to burn through organic matter pretty rapidly and develop or produce a lot of CO2. But it's a topic of actually a lot of funding right now from National Science Foundation and USDA to try to measure these things and get a better handle on it.
That's great. What's your name?
Kevin?
Kevin?
Geyer, G-E-Y-U.
Nice to meet you.
Did a good shot the last one.
Yeah, I guess the thing with the cover crops and whatnot, the main thing is keeping something growing so that you're always producing carbon, sequestering something that's being taken up by plants and it's going to get back into the soil. And if we increase the productivity, the fertility of the soil, we can grow more on that at that point. And it's just a matter of keeping that cycle going. You can't stop. And, again, not put the organic matter on. And so I guess the main thing is to get systems where you always have something growing, not letting things like bare soil, where the sunshine's not producing, there's no photosynthesis there.
Yeah.
So I think that's the main thing. And if we have this, again, this cycle, we just need to keep it. And with the soil in the healthy condition, we can grow more at any time.
I can't think of a better take-home message. It's great.
So, Eric, thank you.
Thank you very much. Thanks for inviting me. Yeah.
Can I just have 1 minute to ask one more question, Barrett? You didn't really talk at all about the role of earthworms.
No, earthworms scare me. I have so many earthworms in my high tunnel, I'm wondering if they're causing a problem. But the role of earthworms really, they move large amounts of organic matter around. There's actually been research showing that you don't need to till the cover crops back in, that you can leave them right on the surface, and that at the interface of the organic matter and the soil, the earthworms are very, very active as long as it stays moist, and they'll bring the organic matter down. And so they have a tremendous role in moving large bits of organic matter around.
I was more interested in you commenting on the role as far as developing soil colloids because of the mucus they produce.
That's right.
And how that affects the soil structure.
Yeah, maybe Kevin can speak more to that.
It's true. I study the microbes more so than the fauna.
What's the effect of rototilling on the earth?
Not good. Yeah, so there are a couple of detriments. The rototilling can kill them physically. It also aerates the soil so the surface dries out, and the earthworms get deeper and deeper. They don't go into the dry levels. So really what you want is exactly what Chuck said, is this ground covered all the time. And that brings the earthworms up to the top and keeps them active. And
This aeration problem?
oh yes, no question about it. They have channels all through there and loosen the soil, so they keep it aerated.
That's why you want to go to the surface wells, because they make those pores down.
Yeah.
Also for water infiltration.
Even if you use a plastic mulch, there's an amazing amount of earthworm activity all the way to the surface under a plastic mulch compared to what it would be for a bare ground.
You got any thoughts on snake worms?
No, I don't even know what a snakeworm is. Is that like a horseworm?
Anybody else ever?
What was the question?
Snake worms. This is an invasive. It's an invasive that has shown up in the forest floor. Am I totally off the wall?
Are earthworms a native? I thought earthworms were native and had been imported.
Oh, some of them have. There are native ones and imported ones. There is one imported one. That's what has me worrying.
I know.
Is an imported worm that's been eating nursery crops.
I know they've been discouraging fishermen from disposing of earthworms in the forest, when they're done fishing.
Oh, really? Oh, because maybe they're buying. Yes. Do you know? Is it the red wriggler? It's not the red wriggler. Which?
I heard it was the red wriggler, but I don't know for a fact.
I'm not sure that it is
Not
the
up
red
here,
wriggler.
they die in the winters up here.
Yeah, I don't think it is the red wriggler. There is an earthworm that they may be raising for fishermen, selling them to them, and it's not the native one. It is the one that feeds on actual crop material.
It supposedly screws up the soil structure in the forest by eating all the detritus.
Oh,
That's the one that I'm talking about. Nobody else has read anything about that?
I have, but because I was nervous that that's the one in my greenhouse. I don't think it is. I think I just have too much organic matter in the greenhouse.
So thank you very much.
Well, thank